I'll record it. Yeah.
Oh, right. One sec. It says recording.
I think because I have just.
Oh, was that you?
Yes. Yeah.
Oh,
So it's getting recorded now, so I can share it.
that's
Yeah.
excellent. Thank you.
No problem. Right. So hi, Jared. Hey, man. How are you?
Hi, I'm fine.
Hey, good. How was your week?
It's
Still busy
bit of busy.
busy still with fixing the server side. Is it
Sorry?
the server up? You said the server was down and
Yeah, it's
so
okay. Other works I like social work.
okay, yeah. So Jason, that's Jared. Jared, introduce yourself. So so this is Jason.
Yeah, hi there, Sharif.
I'm fine. How about you?
Yeah. So
Yeah.
So
I'm in London at the minute, so.
Oh, okay.
Yeah.
Yeah. So yeah. Right. So okay. So we stopped here, right? So I'm just giving a quick recap, Jared, that what we have been doing ever since we have started this to Jason. So so we talked about extension functions, right? Pavitra, did you try to do that exercise?
Yes or no? But there were some errors.
There are some errors.
Yeah.
Okay, anyway, I'll show you my solution and then we'll probably look at it after the class.
Okay, no.
Okay. Right, do I have it here? Let's do it after the class, yeah. So, okay, yeah, so no problem. Right, so today, is Wilson coming? No, he's not. Right, so today we wanted to talk about design patterns, right? So as I was just telling, design patterns are great, so nothing will miss through a design pattern because these are the patterns everyone has come across, and these are the actually the solutions for any problems which have been seen in the past. So we said we can divide them into three different types of patterns. The first type is creational pattern, and the other one is structural, and the other one is behavioral. So we're going to start looking at what are the creational patterns. So as the name says, the creational pattern is for all about creating objects. As we program, right? So we write code. What do we do mostly? We instantiate objects, right? So we create objects. Jason would tell us more from the construction background. You build things, right?
Yeah.
You have been building things, and when we build things, you need a lot of objects, right? The piece of wood, piece of iron, that everything, right?
Lots of material.
Yeah, same. So so same in programming as well, isn't it? So you have been building software, writing objects, right? Creating objects. So that's why the creational pattern is important, because we don't want to create objects everywhere. We want to create it in a way that it'll suit the application, you see, so that it's structured and it follows a pattern, because of every project I have been working on, and whoever is working on for the past, they will be building things in a way that everything is structured. So if you don't have a structure or plan, things don't go well, right? That applies to anything in life, right? So yeah, so same here. So when we create objects, we want to be very careful that how do we create them, and when do we create them, and what's been getting created. So all these things, how, when, what, all that. Why is another good important thing. Why are we creating this object? All these need to be answered, and if we want to answer it, and if we follow the design pattern, that will give us the answer as well, because then because of these are solved before in a way that we will not get into a problem. So design pattern itself solving a lot of problems for us. So if you now say, okay, what is the creational pattern? As I just told you, it's all about creating objects, right? In a way that, it will not mess up the application we're building. The first one we can start with is a singleton pattern, right? There are many, but let's start with the first one, the creational pattern, which is a singleton pattern. How many of you have heard of singleton pattern? I'm sure everyone would have heard, right? But just asking. Jason?
Yeah, I've heard of a singleton.
Definitely.
I'm not entirely sure. I just know they use it for
no problem.
one-time uses or something like that.
Yeah, Charit, you would have used this many times, right? Singleton.
Yeah.
Charit has been coding for a long time. He's a software dev. Into you mostly do web, right, Charit? Oh, he's a full stack. He's a full stack guy. Yeah, he does everything. He fixes server, database, everything. Yeah, he's an all-rounder. Yeah.
Nice.
Yeah. So yeah.
Thank
And
you.
Bavitra is just starting to learn all this as well, you know. So yeah. So Bavitra, singleton pattern, have you heard of it? Have you dealt with this? Have you used this before?
No.
Okay, no problem. Right. Singleton pattern, right? Let's talk about singleton pattern, right? So the singleton pattern is, as it says, is a single instance, right? So if you create an object and the singleton pattern will only allow you to have one instance of that class. Yeah. So that means throughout your application, if you call this object, the object will be always the same, right? Because of its singleton. So we've created the object to be the same instance every time when we ask it, you know, what's the instance, to be the same. Yeah. We'll see an example. And why is it good? You know, why is it good to have the same instance throughout the application? Anyone? Why do we want to have the same instance without needing to create different instances of that class throughout?
Memory?
Yeah.
Something to do with
Correct.
less memory?
Yes, very good answer. Yes, memory, right? Memory plus anything else?
Like object practically we use like store configuration like stuff. We use singleton, then we can access it anywhere.
Yes, correct. Yeah, so the accessibility, right? So we can access it anytime, right? And the other big thing is the state. The object state would not change. Yeah. So the same value will be given every time we call it. I mean, you know, if you're storing a state and even the state changes, you are going to ask the same instance to get that state always, right? So it's the one source of truth throughout the whole application to get the state, you know. It's not going to be like, I mean, having different states because of differences have been created. So memory, yeah, it's a big thing, and it holds the state, so it's the same. It's the one place of truth, you know, for accessing the state we want or the data we want, right? So because of it's being the same instance, yeah. Right. So let's have a look at an example, right? So, any questions so far?
None from me. It's quite clear
Cool.
for me at the moment.
Yeah, cool. Right, I'm thinking. Hold on. Okay, right. So how do we do this in Kotlin? Yeah, that's the big question, isn't it? Okay, let's because I was thinking, guys, now to put this in every time, you know, all the code we have been writing here, let's commit it into GitLab or something, you know, so that you guys can pull it later and look at it. Yeah, that's the only thing which we haven't done so far. Close all tabs. So yeah, let me create. We have just started design patterns. I'll put this in design patterns, and the first one we're looking at is Kotlin file singleton. Yeah, right, done. Okay. Well, yeah, this is the 620 I was talking about, Jason.
Right, gotcha.
Yeah, this is coming with features, man. This is really cool. Yeah, the new Kotlin version is available, guys, which is 1.7.20, and they have improved a lot, and some new cool features have been introduced as well yesterday, and it's very, very good. I'll show you those new ones, you know, later when we come across them, you know. So, and it's very, very good, you know. So, yeah, keep an eye on the new releases come out, you know.
Okay.
Right. Yeah. Right. Oh yeah. So how do we write a singleton in Java. Let's have a look at an example, right? Where was an example? Yeah, there you go. Look at this here. So it's just an example in Java, right? How do we write the singleton? So as we said, the singleton needs to make sure always it gives us the same instance. And you see, when we call the get instance method, it needs to check whether the instance is not null or not. I mean, if it's null, then create it and return it. Oh, yeah, and return it here. So this check you need to be having always. And then you need to have a private constructor so that no one can instantiate this, so there will be always one instantiation. That's when you call get instance, yeah, and so on. See how much we need to care, right, to create an instance, to create a singleton class, yeah. And also, when it comes to singleton, right, when it comes to singleton, what are the other things we can think of? Yeah, as we said, when we create a program or an application, we need to think of a lot of things, I mean, like whether it's performant or, whether it's thread safe or, how the things are, communicating to each other, the communication, whether it's a lazy communication or eager communication, things like that. So just to be giving you an idea that, I mean, when we build applications, we need to think of all these, otherwise, we will get into trouble later, right? So when we create a singleton, every time when you create it, it's expensive, right? As Jason said, it's memory consuming. So you're creating these objects, right? So we need to make sure it's always created once and for the first time, yeah, and things like that. The when part of it, when do we create this object? So we need to be telling the caller that we would only create it the time when this get instance method is called, right? That's the first thing. When we create an instance in Java, sorry, singleton in Java, we need to care about, right? The second thing is this thread safe? Imagine if we have two threads accessing this singleton class and try to create the object out of this. How are we going to manage this to say each thread will create the same instance? Any guess? How would you achieve that in Java? So what I'm trying to say is, did you understand the question? So the question is, we have a singleton, of course, this piece of code, right, in Java. How do we make sure two threads will call this and at the same time it will get the same instance? So I don't want one thread to come and create this and the second one is calling the same method at the same time. How do I make sure this is thread safe?
Volatile.
Yeah, volatile. Or how would you make this call, which is calling the get instance, thread safe? There's a keyword in Java, remember? Synchronize, yeah? So
that's the one.
To make it synchronized. Yeah, so that each thread will access it at a time, even though they're coming at the very first, even though they are coming at the very, very exact time. Yeah, so we have the synchronized keywords and all that. So we need to make it synchronized, yeah? And what about, there are, now not two threads, there are 100 threads accessing it at the very same time. What will happen if you make it synchronized? Yeah, so this get instance method will be called by the first thread, which calls it. If you go very, very, very accurate with the time, with nanoseconds and things like that. So at one point, somebody would have accessed this for the first time, right? So they will start creating it, and the next 99 threads are going to sit and wait until he finishes with it, because it's locked. With a synchronized keyword, we will lock it to say only one thread can just do the business with this and leave the lock open for the other threads to use it, right? So the 99 threads are going to just sit and wait. That is performance. Our performance is gonna give us problems because of the other 99 threads are halted. So they are they are waiting to perform the operation because of, you know, this is synchronized and this is singleton. So what I'm trying to say is we need to care all these, you know, when we create a singleton in Java. So the Kotlin guys come up with a clever solution to, you know, iron out all these so that we developers don't need to worry about it by just saying you create a singleton in Kotlin with just this. Yeah. This is a singleton. That's it. Object keyword makes a singleton in Kotlin. That's it. Nothing else. You know, you don't need to worry about anything else. That's why I said it. I mean, Kotlin is concise. I mean, very, very concise. It's not verbose, you know. So to do that in Java, see how much verbose is this? You see all these lines, and you know, I need to worry about making synchronized. I need to worry about private constructor. What if I mistakenly make it public? Then that's it. Singleton pattern is broken. You know, I'll need to make this static. You know, I'll need to have this if check. Oh my God, it's too much boilerplate, right? So we don't want all of that. This is repeated again and again. So Kotlin guys have made it a bit more, not a bit more, you know, I mean, it's a lot more better than, you know, the Java version of creating singletons. So here, just the object. If you call something object, that is one object is going to be created. One instance of this class is going to be created throughout everywhere you access this. Yeah. So that's why it's the singleton here. Yeah. Any questions so far? Guys, did you understand it?
Yeah, it's where you use in the Java.
Yeah.
You mentioned there was the synchronized.
Yeah.
Keyword.
Mm-hmm.
What is the substitute for that in Kotlin?
Yeah. So if you make this class object, which is a singleton in this case, it is synchronized already for you. So it's thread safe. Yeah, that's what I'm saying. All that is provided for you, implemented for you. But that's what I'm saying. You know, the Kotlin is a language which is an improvement of Java, and it is Java. It's built on top of Java, right? So it's using all the Java language features, but it's built on top of Java to improve the features and the problems we had with Java. You know, all the verbose way of writing code, all the way of you know, expressing, you know, what it does. In Java, you're writing in an imperative way. You know, you need to tell a lot of times what it does. You see here, as an example here, we are talking about what this needs to do. But in Kotlin, you just say how it should just do, you know, how it should be an instance, a singleton. So you just say, expressly say, you know, I'm declaring this is a singleton and you're done with it. So that's why it's always how, you know, rather than what. So the what is more like, I mean, you need to declare it and express it all the time, you know, which is boilerplate, right? If you open another singleton, all these lines are going to be repeated. So why don't we just pack it and make all the other problems come with it into a class itself? That is the library implementation of Kotlin object for us, which is a singleton. Serve the purpose, right?
Yeah, understood. Yeah, definitely.
Yeah, that's why Kotlin is popular, man. I mean, getting better and better in the community. Yeah, demandful. Everywhere people are jumping to Kotlin because of less boilerplate, less verbose, less you name it, you know, I mean, better with features, improved features over Java, you know, threat safety everywhere because of its immutable, you know, immutability is you know, taken care of everywhere, you know, rather than we need to implement it and all that. Yeah. So yeah, how is it for Charit and Pavitra? Any questions?
Thiru, I have a question. What about you told is there 100 of threads?
Yeah.
Because of synchronizing each one have to wait once complete.
Yeah.
How it handle in Kotlin?
Yeah, so it's the same. I mean, no, it's going to wait because I mean, what I was saying was here, if you want to make this thread safe, yeah, this singleton thread safe, we have to make this synchronized, right? Otherwise,
yeah.
A lot of threads can come and start this process, and another will start as well, which can create an instance. And even though it's going to always create the same instance, it can go a bit messy. We can guarantee that, I mean, how things are going to get created, right? So it's going to wait. The other 99 threads should wait because we made it synchronized. Synchronizing means we put a lock on it, saying only one thread can access and, do the business, right? It's going to be the same. So in Kotlin, it will make all of that for us. It will make it synchronized for us, so we don't need to worry about making this singleton class, thread safe. You see?
Yeah.
Right. Any more questions, Pavitra?
No.
Okay, good. So yeah, so this is an interview question, guys. I mean, anyone can ask just, I mean, what is a singleton pattern? There you go. So you just tell this, I mean, in Kotlin, you just call, you just make, you use this keyword object, and that is a singleton for you. You're done. Right. So let's have a quick example. Have a look at a quick example. How do we think of an example here? Let's say, yeah, let's elaborate a little bit more here. So I have a main function. Yeah. Let's say, I was thinking this. Let's say we need to create a list of movies. Yeah. So let's say these are my favorite, favorite movies. Yeah. My favorite movies. Yeah. Which is which can be a list of string. And that would be the list of, how do you create a list in Kotlin? List of, right? And yeah, Harry Potter or something. Yeah. This is my favorite movie. Which has a list. I don't know what is the other film.
Lord of the Rings.
Oh yeah, why not? Why not? But my favorite movie is The Pursuit of Happiness. Man, I love that movie so much, Have you seen it, Jason?
No, I've not seen. I know it's is it Will Smith?
Yes, Will Smith, man. Has anyone seen Pursuit of Happiness? The Pursuit of Happiness. Charit? Voucher?
No.
oh my God, watch that movie. Oh man. I never cried. I never cried watching a movie, even a Tamil movie, right? I've watched so many singular and Tamil movies. Never cried in my life. Yeah.
Yeah.
But when I watched Pursuit of Happiness, every single time I watched that movie.
I was a fan of Harry Potter.
Sorry?
I was a fan of Harry Potter.
You're a fan of Harry Potter. Oh, okay. That movie is a million times better than Harry Potter, I would say. But that's my opinion. Okay, yeah.
That was his real son as well in that movie.
Yes, they acted it so well, Oh my God. I mean, it reflects our lives as well. How struggle is it to, go through this life, right? Every single hurdles we need to jump over and all that, getting a job, performing in the job and, shining in the places and all that. All the other, problems could come across, when you're looking for jobs. Man, Jason, if you look at it, if you watch it now, you will tell me.
Yeah, I'm gonna try and go and have a watch.
Yeah.
I am also curious about. Can you type the name in screen? I can.
Sorry.
Can you type the
okay.
name of
Hold on. Yeah, let's see. There you go. This is the one. The Pursuit of Happiness. Guys, watch it. You will love it, man. I'm telling you. I don't know. That's my taste, though. But you know what I mean. But it is a very good movie. Very good movie. Really good movie. Where do I? No. Why am I putting it here? I can put it here now. Happiness. Yeah. I can actually send the link as well, isn't it? Yeah. Okay. Yeah, that's the name of the movie. Right. Okay. So the Lord of the Rings. Yeah. So let's say these are our favorite movies, right? Yeah. And now we say that's my favorite movies. Shortcuts don't work here, man. Okay. This is my personal laptop, but I have quite another shortcuts in the other laptop. Okay. So yeah. Now say we create mine and yours list of favorite movies. Yeah. So these are my favorite movies. These are your favorite movies. They are the same. Harry Potter, Lord of the Rings, Harry Potter, Lord of the Rings. What will happen if I now print this? It's another interview question. Yeah. Are they the same? So if I now do this, why 3 equals? Can anyone tell me? So I'm checking whether they are the same, but with 3 equals, what does it mean?
Oh, 3 equals. I've not come across that one.
Okay. Charit Bavitra. Yeah, this is the first time we're talking about this in Kotlin. So right. So 3 equals means it's checking the reference. So it's the referential equality, right? It's checking whether these two values you have are actually pointing to the same object. So these the same object? So it's checking the reference of these objects, where they point to. But if you have 2, that means it's checking the contents of these are the same.
Oh.
You know what I mean? So then it doesn't matter about what this object referring to, whether the objects are the same, but it's actually checking whether the contents inside the variables you have created here are the same. Yeah. So if you have 2, that's checking the contents. 3 is checking the reference. So this is called referential equality, right? So okay, so what we'll get if I print this now, what we'll get? What do we get? What would we get?
If you're checking the reference, you might get a funny number.
No. We're checking whether.
Oh, sorry. True.
Yes. Okay. Anyone else? Will it be true or false?
Oh, no, it's different. I think it's false.
Anyone else want to guess whether it's false or true?
I think false.
True.
Okay, so if I try saying true, Jason is saying false, Charity is also saying false. Let's see who wins the jackpot.
Come on, like being at the races.
Come on, at least for once, yeah? Win the jackpot. False!
Okay.
They are not the same.
Yeah.
Yeah, because you know why? We have created 2 different lists here.
That's right.
They are pointing to 2 different list objects. Yeah, in memory. Yeah, so who is the winner? Bavitra is the winner.
Yeah.
She won the jackpot. Come on, how much you're going to share us? Sharing is caring.
That's right.
Yeah, right. So yeah, so this is the thing, guys. So there are 2 different values, but they are pointing to 2 different objects. Yeah, list of creates different objects. Yeah, let's have a look. Yeah, it's creating a new list as list. There you go. It creates a new list. Yeah, again, it's instantiating a new list. Again, see, that's Java. See, it's all just built on top of Java, array list and all that.
Yeah.
Yeah. So always try to go inside the Kotlin documentations as well. Go deeper in and see what it does. See
Okay.
list stuff is always checking whether the element sizes are great, then it's created. If not, it's just returning an empty list. Yeah, empty list is actually a singleton. Let's have a look. See that? It's an object.
Okay.
Yeah, empty list is a singleton. So they are following a singleton pattern here. Empty list means it's always going to be empty, right? So it will be the same instance everywhere. So that's why they create a singleton there. If we want to have an empty list means empty, right? It shouldn't immute. Yeah, right. So yeah, these are the same. But have you noticed the problem? The problem is, why do we need to create two different lists if they are always going to be the same? So if I ask you the same question, say that, I mean, if, you know, we don't say that, I mean, we don't have any, oh, sorry. Say for instance, you know, we don't have any favorite movies, yeah? So, or you just want to start this application by telling everyone's favorite movies are empty, you know? So we can just do this too, right? So nothing, no favorite list added to this list of, yeah, movies. So they are actually pointing to the same singleton object, right? So do we even need to create two different instances as we had it late? I mean, as we just added two different lists. We don't need to, right? So we can assign it to a singleton. Empty list is a singleton in this case. Yeah. So this is one of the examples in a way you can use a singleton, or you could also create your own singleton. In this case, you know, we don't need to, but then, you know, if you want, create the empty movies or something. Yeah. Yeah, that's a singleton for you. So you can do this too. Yeah. No, that's the wrong one I'm creating it. So what's the problem? Oh yeah, of course. Yeah. It cannot be the list because if it's not still a, oh yeah. What's the problem here then? Yeah, well, why is it a problem here for us? Why is it saying red?
List of existing objects.
Yeah. Yeah, the types are mismatching, right? So here we said the val is a list of strings, but we have just created an object, which is a singleton, of course, but we didn't say what type is it, right? So for it, so this is not a list, isn't it? So we can make this a list. So we can we can let this in, let this implements the list interface. Luckily, you know, this list is an interface which you can implement it too. Yeah, now it's a list. Yeah, so we can say this is an empty list. Yeah. So, but what? Yeah. So now, okay. So now, if we print this, what's going to happen? Whether it's going to be false or true. It was false before because there are different instances we were pointing to. Yeah. Now we've created the singleton. So according to what we have just studied, singleton should be the same object everywhere. It should refer to the same object everywhere. So this is going to be false or true now. So are they referring to the same object?
Yeah, it would be true this time.
Bavitra?
Huh?
Would it be true now or false?
This also false.
Okay, why? Okay, so we're checking whether these two variables here are pointing to the same object. Are they